Hello. For some of you, we've been talking about projections. We spoke about the horizontal projection, where a particle, an object, is launched. However, when it is launched horizontally, so it tends to move like this until it starts to go down. Maybe not necessarily like this, but like this until it starts to go down. So there is a force that launches it horizontally, and it keeps on going in this direction. However, we might also, in most cases, you might think a good example of this type of projection, probably a tennis player when they do their first serve. A tennis player, yeah, when they do their first serve, they actually does a horizontal projection, whereby the ball, as it goes to the opponent, it is basically the size of the ball and the amount of force that propels it to move in that direction until before it starts falling down. It overcomes almost every rotational gravitational effect for friction, and air resistance becomes ineligible in this case. There are some of the projectiles whereby it is launched horizontally and vertically at an angle. Suppose we call that angle theta, and that angle is called the angle of projection. How does the object move until it gets back to the plane, if it is on the plane, horizontal plane? So what we can witness here from the diagram, this is the path or the trajectory that is taken by this object. It's like this. So we've got the horizontal movement. So when you project it horizontally, when you project it at this angle theta, the object will move in the horizontal direction and in the vertical direction. And in the horizontal direction, it moves at u cos alpha. And in the vertical direction, it moves at u y is equal to u sine alpha. Basically, this is an issue of the trigonometry involved. Suppose we are saying, imagine we are moving on a horizontal plane. Let me just put a horizontal plane here. And if I have an object that is here, and I tie a string here, and I start pulling it in this direction. So what we can actually see is I'm pulling it this direction. I'm pulling it at this angle, which I can call theta. So it is at the same time as I'm pulling horizontally, there is a force that is going up here, and there is a force that is going to the right. So the net force of these two is what creates the movement in the horizontal direction. So if I apply a force F here, according to the Pythagoras theorem or the trig function, the vertical force which is going up here can be simply calculated by saying this F here and this horizontal force in the y direction, which is the opposite. So we can see that sine theta is just f of y over f, and we can see that cos theta is equal to f of x over f. Hence, we have these two formulas that says the horizontal component is u cos alpha and the vertical component is u sine alpha. So that's basically the formulas we use. Let us look at some examples to make this more easier. So suppose we have got a question that says a particle is projected from a horizontal plane at an initial velocity of 40 meters per second, and the angle is given as alpha, where tan alpha is 3 over 4. So the key word is this part here, initial, and this part here, tan alpha is equal to 3 over 4. If I'm to do the trig ratios here, I can create a triangle that you can see, a right angle triangle, the Pythagoras theorem, one of the most important theorems. Tan alpha is 3 over 4, so this is 3 and this is 4. This is a very easy example because these numbers are quite direct since are Pythagorean triples, so the hypotenuse becomes 5. What this tells us is sine alpha is 3 over 5, opposite of hypotenuse, and cos alpha is 4 over 5, adjacent of hypotenuse. So if we are to model this question into a practical reality, we are saying a particle is projected from a horizontal plane. Let us say we have a horizontal plane that looks like this, and a particle is projected from this plane. So what we can see is it takes the path that looks like this and it comes back. Let me just try to make it look a bit more like this. So what are the assumptions that we know? One of the assumptions is it is projected with an initial velocity, which is u is equal to 40 meters per second. So what is the vertical, the horizontal component of this force? Since this is theta, actually this is alpha, we can say the horizontal component, let me just put it in a different color, is this direction, and I'm going to write it as ux is equal to alpha is equal to u cos alpha, which is basically u, which is 40 times cos alpha, which is 4 over 5, which I believe this is going to be 40 divided by 5, and that is 8, and 8 is equal to 32. So this object does move at 32 meters per second in the horizontal direction. In the vertical direction, uy is equal to u sine alpha, which is going to be 43 over 5, and again that is going to give us as 24 meters per second. That's what is u all about. So we can actually say the initial velocity, we can present it as 32 and 24 as a vector, or we can write it as 32i plus 24j. And clearly it's quite clear that if we perform the Pythagoras theorem here to find u, we find u as 40. So that's one of the assumptions we know. The second assumption is we know that as the object is moving in the horizontal direction, acceleration is 0. So hence the speed that it is moving until it gets to this point here is going to be constant. That is, it is going to move at 32 meters per second until it finishes its trajectory as well. So now having to understand that makes it now easier for us to answer the question. The first question says find the horizontal and vertical components of the initial velocity. So that was your A. So our A is done, 32 and 24. B says express the initial velocity as a vector in terms of I and j. So u is going to be equal to 32i plus 24j. I had already done that here. So that's how we answer that. All right. Let us go to the next example, probably a much more complicated one. A particle is projected with u as 3i plus 5j. This is the velocity of projection. So those that are quite ahead here, you can see that u has already been presented as a vector. So what does this tell us actually? This tells us that it is moving 3 and 5 like that. So the speed, which is we can call u modulus, is just the square root of 3 squared plus 5 squared, which is equal to 34. There's no need for me to simplify this into decimal places unless specified by the question. So the question says find the initial speed of the particle and its angle of projection. So the speed is 34 and the angle of projection is simply tan alpha. which is equal to 5 over 3. This further implies that alpha is equal to 59 degrees to two significant figures. So the initial speed is 34 meters and the angle of projection is 59 degrees. This is basically the introduction to a projection that is done at an angle.